Hello everyone. Here is the video for you about empirical formulas. So the first problem that you had to work for me was, what is the empirical formula of a substance composed of 56.6% potassium, 8.68% carbon, and 34.7% oxygen? The first thing that we'll do is to assume 100 grams. So we will remove that percentage symbol and put a gram. So now you can see that we have grams of potassium, grams of carbon, and grams of oxygen. Our second step is to determine how many significant figures we have. And we can see, since they're all whole numbers, that we will have 3 significant figures. Next, step 3, please find each chemical on your periodic table: potassium, carbon, oxygen. Determine what the molar mass will be to 3 significant figures. So we can see that we're going to list them as potassium, carbon, and oxygen. We want to put them in the same order that they were given in the problem. That usually will help us determine what the formula will be. So for step 4, we're going to convert the grams to moles using the molar mass. In this case, we'll put the grams in the denominator and the 1 mole in the numerator, using units and chemicals to identify our numbers. So there's the first example. There's potassium. The 56.6 grams is from the original 56.6% given in the problem. 1 mole potassium divided by 3.91 grams was found on the periodic table. The next step will be to cancel the grams and the potassium, just leaving moles of potassium as your label. Please don't cancel the numbers. So we can see that what we have left is 1 mole potassium, and that's what we're looking for, since we would like to convert the grams to moles to get the lowest mole ratio as our answer for the empirical formula. So you can pause this if you'd like and repeat with steps for carbon and oxygen. Well, here we go. Step 5. Divide each calculated number of moles by the smallest number of moles that you calculated. So when this was calculated, 0.723, which was the number of moles for carbon, that was our smallest number. We had 1.48 moles potassium, 0.723 moles carbon, 2.17 moles oxygen. Now some of you might have thought, oh, 14 divided by 7. Or it could be, oh, look at that. Carbon is just divided by itself. And look at that, 21 divided by 7. So if you did, then you were ahead of the game. You just have to be careful where you put those decimals. So when I'm dividing by the smallest number of moles, which was carbons, 1.48 moles of potassium divided by 0.723 equals 2.04. Now we need to round that number to the whole amount of moles that I would have. So the rounded number is 2 moles of potassium. I can see for carbon I have 1 mole because the 7.2 moles was divided by 0.723. And then it leaves us with oxygen. 0.21 moles of oxygen divided by 0.723 equals 3.00, which I will round to 3 moles of oxygen. So the last step will be, we will use the rounded moles of each chemical to write the empirical formula. In this case, it will be K subscript 2, C, O subscript 3, and this is your answer. So some of you may say, oh, that looks like potassium carbonate, and you would be right. This is the lowest ratio of chemicals in the original experimental sample. Some of your other problems you'll see are only nonmetals. This is a metal with 2 nonmetals, and frequently when you have that, you will end up with the lowest ratio. and that will be your answer for the molecular formula, or the formula, the ionic formula. However, many times when we're using a metal, we won't know if we have for the transition metals +1, +2, +3, etc. So this will give us our lowest ratio, and then we can use the second part of this lesson, which will be on finding a molecular formula. In this case, it wouldn't be a molecular formula, but it would definitely allow us to find out which of the cations we had for a transition metal. I hope you found this interesting and that you're able to do your work. And if you have a question, you know where I am. Thank you.